Welcome back to Summarize Science. Today, we're looking at a fascinating new way to edit images, but not just one image at a time. Imagine you have a set of photos of an object, like this chair, taken from multiple angles. AI is great at editing a single photo, but if you try to edit each of these pictures separately, you'll quickly run into problems. The lighting won't match, the textures will flicker, and the illusion of a solid 3D object will be completely broken. This paper, Coupled Diffusion Sampling for Training-Free Multi-View Image Editing, presents an elegant solution to this very problem. Previously, trying to achieve this meant building a full, explicit 3D representation of the scene first. This process is often slow, requires a lot of computing power, and can be unstable if you don't have enough photos. But the researchers here asked, can we get 3D, consistent edits without the headache of building a full 3D model? Their answer is a new technique called Coupled Diffusion Sampling. Instead of one complex process, they use two specialized AI models that are already experts in their own fields. Think of it like a collaboration. One model is an expert at 2D image editing, able to apply any style you want. The other model is an expert at creating sets of images that are perfectly consistent from a 3D perspective. During the image generation process, a coupling term forces these two models to talk to each other and agree on the final output. This ensures the final images have both the desired edit and the crucial 3D consistency. And the results are pretty stunning. Here in Figure 4, we can see some examples of multi-view stylization. When asked to create a rusty red Jeep, the method produces a consistent look across all angles. Compare that to other methods, which either lose the Jeep's identity or produce inconsistent, flickering results. The same applies to making a green armored ironsmith. The result is coherent and believable. It's not just for changing styles, it also works for spatial editing, which is moving objects around. As you can see in these examples, their method correctly moves the vehicle while preserving its appearance from all sides and creating realistic shadows. The baseline methods struggle to keep the object looking the same, especially on the back views. The technique is also incredibly flexible. It works for text-based relighting, changing the scene to glowing neon or a beach sunset with impressive consistency. It can even be paired with different AI backbones, like the more advanced Stable Diffusion XL, to produce even more realistic results. So, let's recap the key takeaways. This research introduces a training-free method to achieve multi-view, consistent image editing. It cleverly couples an existing 2D editing model with a multi-view generation model, avoiding the need for slow, explicit 3D reconstruction. This makes high-quality, 3D, aware editing more accessible and efficient. What does this mean for the future? The researchers suggest this paradigm could be extended to video editing. Imagine applying complex styles or edits to a video and having them remain perfectly stable and consistent as the camera moves. This work is a significant step towards that reality. That's all for today. Thanks for watching Summarize Science.